Hello. We will continue our discussion on IP routing in our computer networks and internet protocol course. So, last day or in the last lecture I should say, we discussed about this IP address and allocation and how the routing come into play. So, today we will be little more going deep into the things. We will be having some basic introduction to this intra-domain routing, and in the subsequent lecture we will be going to more detail about the routing protocols, right. So, when we talk about routing, just to have a quick recap of the things or something already you know. So, one of the major feature or one of the major aspect in internetworking or our communication between two device connected on the network is to forwarding, right, moving packets between ports, right. So, in this case we are looking at the network port. So, it can be from the host one end, one host to other, intermediate host to router, router to router, router to host and anything. So, how things can move. So, it may be on a single hop distance, it may be on a multi hop distance. So, it can be directly connected or it can be connected over a large network. So, look up destination address in the forwarding table. So, as you remember in the last lecture we discussed about the routers basically maintains a routing table. So, that means, if it gets a packet for a particular destination, it says that it forwards a packet to a particular path or particular so to say port or next destination or like that, right. So, it has a routing table which has ideally all the possible destinations and what should be its next hop or what should be the path to be forwarded, right. Or if it is in the end, let us we will see that one in subsequent lectures when we talk about layer 2 and type of things, find out port or output port and MAC address, right. What is the port and MAC address pair, right. Finally, what we know that it finds a logical path, this at the IP level. Finally, in order to forward the packet, we need to get that hardware address or the MAC address of the destinations. So, that is done by this some address resolution protocol. Okay, we will come to that. So, routing is a process of populating. If you look at that what this other way of looking, one is forwarding, another is the routing protocol, right. So, one of that is that it is a process of populating the forwarding table or the routing table, right. So, again I repeat. So, router is a layer 3 device which has a lookup table or routing table or forwarding table, interchangeably we are using, and if a input packet comes for some destination, it consults the routing table that where need to be forwarded, it forwards it. Now, overall internet network is a large network and that is dynamic and so on and so forth. So, in other sense, the router one of the objective is to maintain this routing table. How this routing table will be updated, so that any packet comes, it gets that correct path to be forwarded, right. So, the router exchanges. So, in order to update the routing table, the routers should exchange messages about the network they can reach, right. So, if a router 1 is connected to the router 2 and router 6, 7, 8. So, these routers exchange messages who they are network they are connected and the other things gets updated. So, find what is my objective thing, find the optimal route for every destination. So, given a destination finding the optimal route for every destination. Like if we try to look at the analogy, finding if I am visiting a place. So, one of the objective is that find the optimal route to visit that to reach that particular destination. So, optimal route may be the shortest distance. I may look for less congested route. I may have some other criteria, like I want to travel through a route which is safer and type of things, right. Nevertheless, based on my criteria, I want to find out that what is the optimal route from this source to the destinations. or for that particular router to the destination, which way I should proceed. Now, if we look at routing algorithms, so it is getting some local forwarding tables are there. If these are the some for our discussion sake, these are the different header values, then these are the links it will be forwarded, right. If it is 0100 to 3, 0101 to 2, 0111 to 2 and so forth, and I have that. So, given a header value, if this one, it consult this table and forward it to 2. So, one is this objective of the forwarding the packet is one of the work of this particular router. Another, this table needs to be updated for this router, right, and every router had their corresponding table and it goes on forwarding the things. So, what we try to argue, if somewhere or other if these tables are maintained properly or they are able to update themselves in a proper in a regular fashion, then the packets can be routed from anywhere in the internet to any destination, right, any source to any destination through this different router. One thing we should keep in mind in when we talk about internetworking, these are some sort of a so called distributed system, and most of the cases they are loosely coupled or quote unquote autonomous systems, right, or several autonomous systems, though there are domain control will come in this subsequently in this talk. So, in other sense I do not have a control that what that other router will do. If it is the router is in my domain, then I have some control, but most of the cases if it is in the other domain I do not have any control. So, there is some sort of a message exchanging are going on at that, and this routing table is getting updated. If these routing tables are updated, then we go on hopping the things. So, one of the issue which come into play is the stability, right. So, stable routers are often preferred over rapidly changing ones, or that in other sense the routers where the routing table is stable, right. So, that the exchanges are much faster, etc. If the routing change, because based on the routing table or this lookup table, these packets are routed. So, if it is very dynamic, it is unstable, then the whole things is unstable. So, that is one important aspect of the things, right. And there are several reasons. One way is the manageability will be better, right, hard to debug a problem if it is a transient, right. So, if it is a if it is very dynamic and something at the when it is updating, getting changed, etc., that will be difficult to problem to manage this overall process. And if it is a large network, then it is a or scale of internet, it is a very difficult thing. Second reason is that higher layer optimizations like TCP RTT estimation, like as you have, if you remember when this in this particular course we discussed about this TCP and round trip delay and type of things, and there will be challenges there. So, imagine suppose it is alternating every 500 millisecond or 50 millisecond or 5 millisecond routes, and then how things will be there. So, I need to, so more I look for the stability, then I am less on the optimality, right. So, if it is optimal things, means at that time I want to find out a solution which is the optimal solution, and for that I may need to be more dynamic, or in other sense we are basically fighting between stability and optimality, right. I want, if suppose ideally if nothing is changing, then it is a more stable, say for hours together nothing is changing, but you may not get a optimal thing. But if I allow it to change every now and then when there is a change, then it is more optimal, but then the stability is hampered, and that may cause different other issues. So, there should be some way of looking means need to be optimized and things. And that is why when we talk about performance analysis of the network and several other matrices, then we try to look at that what amount of the stability, optimality and etc. we are looking for. So, so what we see, so we have routing algorithms. So, routing algorithms primarily what it does, it basically allow me to maintain these routing tables, right, individually at every routers. And now the routers becomes independently once it gets a packet and goes out and so and so forth. So there can be global or some sort of a centralized taking a call, taking the global consideration, or it can be decentralized, right. In global, all routers have the complete topology. So, if I have the whole topology of the whole global scenario, then I can make a optimized scenario, right. But it may be possible over a small network, but it may not be possible on a large network. Whereas, in decentralized on the other hand, only know the neighbors and share information from them, right. So, I only know the neighbor. So, if the router R I knows its only neighbor J K L M and it shares information about the thing. Similarly, another router R J takes the things and going on. So, it is a decentralized fashion. So, I am not looking at the whole world or the whole network and taking a call, but more taking a call taking at the only the local neighbors. So, that is one. So, we have a option of there is two way of routing will be intra-domain and inter-domain routing. So, inter-domain all routers under the same administrative control. When we say intra-domain, it is under the same administrative control. It may be large network, like in IIT Kharagpur we have say around 50 odd networks under the control of IIT Kharagpur itself. Whereas, inter-domain which is decentralized scale to internet. So, huge amount of networks and etc., which are to the scale of internet. So, these are inter-domain. So, these are the broad category of the things. We will come back to those things shortly. So, we have two type of broadly routing. One is inter-domain and one is intra-domain. Intra-domain is somewhat all routers under the single administrative control, like IIT Kharagpur network or any such networks, or whereas inter-domain is decentralized. So, like scale of internet and type of things. Now, as we understand, these two aspects has two routing phenomena has different type of considerations, right. Once you have everything under control, you have a way of looking at the problem or the routing algorithms, and if you have that it is a decentralized and not under a single administration, we have to do. So, today we will be looking at some basics of inter-domain, rather again in subsequent 1 or 2 lectures we will be looking at the intra-domain and then we will talk about inter-domain routing, right. So, before that we take up couple of issues to so that we understand that what is the challenges, right. One is the issue of optimality, right. So, I can look the whole network or the portion of the network under consideration as a graph. So, nodes the router and links are your edges, and then the edges can have variable weight based on different considerations. It can be the congestion level and or length of the distance and a different type of consideration we can have, right. So, assign cost to each edge based on latency, bandwidth, utilization, queue length, etc., right. So, this can be the cost to edges. Now, our problem is finding the lowest cost path between the two nodes. So, based on my metric or our metric under consideration, I want to find out the least cost path between node A and node B or source node and the destination node. So, each node individually computes the cost. Now, if each routers had the capability to compute the cost and in a distributed fashion, and then I find out the overall cost of looking at the things, right. This is now what I looking at is a optimal solution, but it may not be possible to always get a optimal solution. So, we can go for suboptimal solution. In some cases, we will see that a concept of default route is there. If I do not found a right route, then I may have a default path to forward the packets. Other issues which are definitely come into play is the scaling issue, like how it scale, how the algorithm scales. So, each router must be able to forward based on any destination IP address. So, our bottom line is that whatever is the destination IP address, the router should be able to forward. So, given the address, it needs to know the next stop consulting the routing table or the forwarding table. So, it has to know that where it should go next. So, one of the naive approach may be have a entry for each addresses, right. One that I can have entry for each addresses, but however, that will be a usually there can be huge number of entries then, right, to the scale of 10 to the power 8, 10 to the power 9 type of entries if you consider the all systems etc. across the domain, right. So, it will be huge number of address, then that may not be practically feasible. So, one solution may be entry covers a range of addresses, right. So, I have a things which covers a range of addresses, like outer IIT Kharagpur router takes care of the rest of the 20,000 odd systems within the campus, right. And systems in the sense systems, devices etc., network enabled devices within its domain, right. But for the external world, it looks at only one router or maybe one or two routers which are looking at the things, right. So, that may be, so I do some sort of a address aggregation on the things. So, one is that we can't do this sort of things if the address are assigned randomly, right, like Ethernet address or hardware address which comes from the manufacturer, we will look at when in our subsequent lectures. So, we cannot do something which is randomly assigned, right. Address aggregation is a important aspect which we are looking at. Address allocation should be based on network structure. So, I can aggregate addresses provided that is the in the network structure. Now, if you look at some type of analogy, when we look at our normal postal addresses etc., we are able to club them together because there is a sense of inherent aggregation in it. If it is a randomly things, then making things very difficult, like if the house number 1, 2, 3, 4, 5, 6 etc. are closely in a particular locality, then sending the particular forwarding the letters or sending letters with the postman is easy. But after 1, if it is 101, then 49, then 216, then it is very difficult to pack them together or things. So, that it is that otherwise what we require is that some sort of a that addressing mechanism itself favor this aggregation. So, that may be one of the requirement of the means one of the way of looking at it. So, aggregation is important. Now, let us come back to our basic problem. So, what we have seen, these are some of the things which we try to address, that scalability, optimality, stability and of the several routing protocols. And if we look at the other way, this again come back. So, what we have that we can have a way of direct delivery, say two systems are connected by a cable and then I directly deliver one packet to another, right. Or I can have indirect and delivery system, right, or I can have multiple things. So, I have in this case a router which forwards the things etc., and there can be multiple where the routing come into play. So, one route method that if I want to, I can have a lookup table like that. If I want to go to a particular host, this is the series of things I need to go, router 1, router 2, then host B, right. So, it is explicitly specify that where things are there. So, it is route method is explicitly specified that this is the route by which you go. Other way, I can only say that it is on the next stop. I only specify the next stop. The next stop takes care of that where it should go, right. That in the routing table of A, in order to go to host B, in this for host A, it says that in order to go host B, you need to go to router 1. Router 1 says in order to go to host B, that is the router 2 is the destination or the next stop, I should say next stop. Routing R2 says that it is connected with this particular network. So, you can directly, there is no next stop, you can directly go to the things. Now, you see this is the next stop based things. So, individual routers R1 and R2, they maintain that routing table that given a destination where it should be pushed, right. So, that is next stop based thing. Then we can have host specific versus network specific. Last class, if you remember, we are looking at that it is router is primarily between networks to network, not meant for host to host, right. It is not like that cannot be done, but it is primarily for network to network. So, if it is in the particular router a host S, on the host specific method, if it is destination is A, then R1 is the next hop, B is R1, C R1 and D R1. So, for all things are there, and for routing table for host A is based on the network specific thing, that in order to reach, because A, B, C are all connected to this network N2. So, it has a one thing, if it is a network, that in order to reach N2, that R1 is the next router, right. So, this network definition. So, instead of taking individual host, I take we consider here the network where the hosts are lying, and then I forward the packet on the base of the network, right. So, there is a concept of default route. If I can't find something where to be forwarded, then where should I forward? So, there is a default route, like in order to go to network N2, push it to R1. In order for any other network, push it to R2, right. So, this is a default route. So, there is a concept of default route. If it is doesn't, if it can't find that where the routing table things are there, it will put it to the default route. Now, if we look at the basic modules or very fundamental structure of the a particular router. So, once it received a packet, you need to extract the destination address from the IP address block. So, these are routers are, as we discussed earlier, that these are layer 3 switch which has enabled up to network layer. So, it opens up to the network layer and extract the destination address, and the next of destination address and it next hop address and the interface. So, it extract the net address, search the particular routing table or the forwarding table, and find out the next hop address and the interface number. Like it has to go to that particular address and to the interface number, right. And what happens when I want to push the packet to the things? I need to know the MAC address or the hardware address of the next hop. For that, I require a ARP protocol. So, that we will discuss later on. So, ARP protocol, so that I know that what is the next address and push it to things. So, in other sense, I have some sort of a net mask, network address, next hop address, and the interface of the router where it need to be pushed. Like here, what we are having, there are several network, like starting from 180, 70, 65, 128/25, here 2014.16.0, and it is connected with different interfaces of this particular router, right. So, it connected to the different interfaces of this router, and there can be a default route one of this interface, right. So, this is a connection for 201.4.16.2/22, 180/70/25 and so on and so forth. And there can be other router connected to this type of interface. Now, if I see for router R1, if we look at, if it is a /26 type of net mask with this network address, then the next hop is M2, right. Okay. So, if you look at, so if the net mask is /25 and the network address is 180.70.65.128, then the next hop is M0, right. Similarly, so and so forth. So, /24 201.4.22.0, it is M3, right. So, this is the address where it goes to this network, right. 201.4.22.0, the next is /24 in this network. Here it should have been M3 out here, there is a typo here, not typo, that M3 did not came up into the this particular interface. So, in other sense, the routing table of this, what it says, when it is this net mask. So, when it gets a packet, it checks with this net mask, if the address matches, it push it to that particular things, right. So, I get a input packet from somewhere, then I extract that particular destination IP, do a masking, if the address matches with these network addresses, is push it to that interface. If it does not matches, then it push it to this default interface, right. Like some example, forwarding process, if the packet arrives at R1 in which the destination address is 180.70.65.140, right. So, if it is there, so it does at /26, because as you remember, so we want the longest prefix first, right. So, 26, 25, 24, 22. So, first it does a /26 applied, the result is 180, 70, 65, 128. You can apply those this type of mask, like that means 26 1 followed by res zeros, and apply to this, that value will get that these values, and this does not match with the corresponding address, right. Then it goes to the next /25 and it gives a value of 180, 70, 65, 128, and it matches with the this one, the second entry of the thing. So, it push it to the M0, right. It matches with the corresponding, and the packet is interface M0 passed to the ARP for further processing. Now, what M0 interface, in order to go to this M0, what it has to do, it need to find out the hardware address of that particular interface. So, it does a ARP resolution, address resolution protocol, right. So, address ARP typically changes a maps a IP address to a hardware address. So, if it goes for a ARP request, it returns that what is the hardware address of that particular device. So, that packet, the frame at the layer 2 level can be forwarded. So, so ARP things will be discussing later. So, not immediately bother about the ARP, but see, if a packet comes first, it follows these things in this order, right. As we know that the we want the longest prefix match. So, 26, 25, first 26, then 25, 24, 22, if does not match, go to this default, right. So, say another example. So, the forwarding process, if the packet arrives at R1 with 2.1.4.22.35, again do with a 26, is come up with a result 21.4.22, which does not match with the corresponding, there is no corresponding this. It then goes for the next /25 and does not match with the row next entry, does a third one in the 22 which matches with the corresponding, right, and then it goes to the this one destination, that it goes to the particular M3 and the address particular resolution again has been, it will be done, right. So, what we see here, that given a packet and given this type of net masking and looking at this, I can basically forward the packet to the to that particular destination interface, and there is a address resolution. That means, I need to know the hardware address to forward the packet or the frame at the layer 2. So, for that as resolution is required, but the primary routing decision is taken care by this thing, right. So, what we see, there may be a need of address aggregation, right. Like in this case, say, a organization 1, 2, 3, 4 may be taking service of ISP and have different type of network addresses, right. So, I instead of having all those entries, I can have a particular network address and then I can have a next stop type of things. So, I can, so in this particular thing I can have a entry like /26, if this network address is this, next stop is M0, M1, M2, M3 and M4, whereas in the routing table 2 I identify that all those things as a single network address as /24 and it push it to the M0. In other sense, for this rest of the world or this routers R2, this is aggregated as a single network, as with a mask of /24, 140.24.7.0/24, and any packet coming with that, it will be forwarded to this packet, right. So, this is the way of looking at the things. So, this address aggregations helps us in clubbing these two, all this together for the rest of this. So, you see, for the entry of the R2 becomes much simplified, right. So, if instead of this 4 organization, if 400 organizations such like these things will be, it will be heavy, a huge load on this type of router, and the processing time will be much higher, because it need to go to this scanning these things. So, we come as a, there is a concept called autonomous systems, like correspond to the administrative domain. Internet is not a single network, it is, there are several autonomous systems reflect organization network. So, there are different autonomous systems which have some authoritative control or the administrative control of the network, like in this case university like Stanford, a large company, or IIT Kharagpur and type of things can act as an autonomous system. So, goal is autonomous systems want to choose their own local routing. So, within the autonomous system, the say IIT Kharagpur, whatever the internal intra IIT KGP routing will be there, it can choose. ASS wants to set up policies about non-local routing. So, whatever for the non-local routing, for the external it can set up a policy. Each AS autonomous system is assigned a unique 16-bit number. Like this is a scenario of autonomous systems. So, we will be going little bit on the that how these routing structures are there. There are backbone routers and other type of things, but nevertheless these are the different autonomous systems, very loosely if you like to see, and these are different networks. They have a bunch of routers and type of things, and they can communicate between each other. So, mostly we say this between the ASS, or what we look at as a mostly as a policy based routing, whether within the autonomous system, that is the local or intra, the autonomous system, individual autonomous system has the authority or total control over the network and decide on the routing as well. And there are different type of AS traffic, local traffic, packets with source and destination in the local AS, transit traffic passes through the AS, stub AS connected to one single autonomous system. So, that is the type of stub AS, multi-home net connected to multiple autonomous systems, carries no transit traffic, right. So, it is connected to the multiple autonomous system and push it to the respective. Transit autonomous system connects to multiple AS and carries transit traffic, right. So, there is a multi-home where it is not carrying the transit traffic, but connected to the things, and there is a transit AS. So, finally, we come to that intra-domain routing with within an AS. So, single administrative control, optimality is important within that thing, that optimality is important factor, contrast with inter-AS where policy dominates, whereas we will see that in our next subsequent, not in the next lecture, subsequent lecture, that inter-routing protocol BGP, where we will look at that policy based routing or the inter-AS. And predominant intra-domain routing algorithms, one is distance vector, requires only local state, less overhead, smaller footprint. It is sometimes difficult to debug, can suffer from loops, we will look at it. There is another thing called link state, have a global view of the network. What we are talking about the intra routing, simpler to debug, requires global state, that is overall state of the network. So, if we look at the routing protocols, so we have intra-domain and inter-domain. Inter-domain is distance vector and link state, inter-domain is path vector, link state is RIP and OSPF, and path vector is BGP. We will discuss those things in little detail. And just to have a view of this distance vector routing. So, in a distance vector, each node shares its routing table with its immediate neighbor in a periodical manner at every time interval, say every 30 millisecond or so, or based on the things, and when there is a change. So, whenever and when there is a change, if there is a change, it will change, or it will go on sharing the things on a beckoning the things, right. And based on the things, other things decides, like if I say A has a direct connection to B where 5 is there, A has a connection to C where 2 is there, 3 is there, and so on and so forth, right. Whereas, A do not have any connection to E where it has go to through C via C and like this. So, it goes on updating the thing. Similarly, so for D, it is only connected to A, it has different paths to look at the thing. So, if you want to go to B, it has to go via A, and the cost for to go to D to B, the cost is 3 plus 5 8, right. So, there can be different type of paths, we will look at that what are the different lines. Nevertheless, if you see every router is having his routing table, that if you want to go to these networks, where it should fall. There could have been another entry here, that is default, if it is something which is not known, where it should forward to, right. So, if we initialize at the initialization at the initial step for A, where nothing is known, say A starts up. So, for A to A 0, A to 5, because these are connected, but A to A does not know where E is. So, it is infinity. So, when it gets A, but C knows where E is with 4. So, next time it gets the beacon or the update from the C's router update, then it updates it with the things. How this update process will go on, we will discuss in our subsequent lecture. So, this way it goes on doing that. So, we will be discussing more detail on taking into this inter-domain routing, looking at different RIP, OSPF or distance vector and link state routing in our subsequent talk. So, let us stop here, and with that basic understanding of what is routing, what are inter-domain and intra and inter-domain routing, and in the subsequent lecture we will discuss in detail those things. Thank you.